These problems here will serve as a good reminder for the skills that you're going to need in this video. So please pause the video and do these warm-up problems. Come back and check them when you're done. Pause the video. Here are the answers for these warm-up problems. And while you're looking at that, I'm just going to write down for review when we use open circles versus those closed circles. Okay, so if we're going to use an open circle, we would do that if we had the less than or greater than symbol. And for closed circles, those get used when you have a greater than or equal to or a less than or equal to symbol. And the big point there is it's whenever you have an equal to symbol attached to the inequality that you close up those circles, meaning that endpoint or boundary point is part of the solutions of that inequality. Gotta be green, gotta be mean, gotta be everything more. Gotta like me, gotta like me, gotta know what I gotta know. I can be brown, I can be blue, I can be fire and sky. Gotta be anything you like. Gotta be green, gotta be mean, gotta be everything more. We're going to start with the steps to graphing inequalities. Your first job is to graph the line, just as you would maybe in slope-intercept form or in intercept form. Your second step is to determine if you're going to use a solid line or a dashed line, and this relates to the green notes we wrote on the first warm-up page. You're going to use a solid line if your inequality has a equal to sign in it. So if it's a greater than or equal to or a less than or equal to, the line you will create will be solid. On the other hand, if there is no equal to symbol, you're going to use the dashed line. And by that we mean this. Okay, so here's your solid line for an equal to symbol, meaning any point on that line is included in the solution set when it's solid. But if it's a dashed line, those coordinate pairs will not be a solution of the inequality you are looking at. Your third step is to pick a point. And you're going to pick that point and you test it by plugging it into the inequality. If your coordinate pair that you picked is true, you shade over that point. If you test that point and it doesn't work, you just simply shade the other side of the line. So graphing inequalities is all about shading. But let's talk about solutions to inequalities before we get to the graphing. So a solution to a linear inequality is any coordinate pair, which is written as x comma y, that makes the inequality true. And here's an example. We're going to test if the coordinate pair 1, 2 is the solution of the inequality that's listed. So in order to figure out that, you simply substitute in this case, y is a 2, and our x is a 1, and you test it out and see if you produce a true statement. So is 2 less than or equal to 4 minus 2? Well, 4 minus 2 is 2. So the question is this a true statement? Is 2 less than or equal to 2? And the answer is yes, because they are equal. So this is true, which means that that one coordinate pair, 1, 2, is the solution of the inequality. But truly, there are an infinite number, or can be an infinite number of solutions or coordinate pairs. And that's what makes inequalities so special. Let's begin with this problem. Our first job, as it was stated, is to graph the linear inequality, as if it was an equal sign there. So that means we put a dot, or a point, at our y-intercept, and our slope is a -2. So we need to go down 2 and right 1 and create a line. But you have to remember that sometimes your lines are solid or dashed. So look at the inequality symbol. Would this line be solid or dashed? And hopefully you said dashed, because that would mean any coordinate pair on this line is not part of the solutions. Alright, so now that you've graphed this, your job is to test a point, because we need to determine which side of this line we're going to shade. And you can pick any point you want on either side of the line. So any coordinate pair from below it or any coordinate pair from above it. So I'm just going to randomly pick a point. You could pick a different one if you wanted to. I'm going to pick, let's take this one. This coordinate pair would be 3, 0. And so I'm going to test 3, 0 in this inequality. If my solution turns out true, then I know that all my solutions are on that side of my line. So 0 would go in for y, 3 goes in for x, and then clean it up. I get negative 6 plus 1 is a negative 5. So the question is this true? Is 0 greater than negative 5? Because the answer is yes, it means you found the correct side that contains all the solutions, and we shade it. So any coordinate pair above the line here would be true for this inequality. And of course, we'll try another one here. Write down this inequality, and then begin by graphing it. Your y-intercept is where you would begin, and that's at a negative 4. And your slope tells you to go down 2 and right 1, 2, 3. The next question, solid or dashed? This one is solid because it has that equal to as part of the inequality symbol. And then your next job is to test a point. Pick any point. And if it's convenient and far enough away from the line, 0, 0 is pretty straightforward. So let's test 0, 0 by substituting it in. And then clean it up. And ask yourself, is that true? Is 0 less than or equal to a negative 4? It is not true. Therefore, we would not shade the side with the test point 0, 0. We just simply shade the other side. There's really no need to test a second point. But if you're insecure or unsure, go ahead and do it. And then this one should technically go away. And you've just graphed a linear inequality. Here's another linear inequality. This one is written in standard form, however, because your x and y are on the same side of that inequality symbol. So you could convert this into slope-intercept form, or you could graph it using intercepts. And just to practice using intercepts, I'm going to use those. So if I'm looking for my x-intercept, that means I'll set my y value equal to 0. So I will get 4x, my 2y disappears, and I am left with x is less than or equal to 3. Now when I'm solving those, I just treat the inequalities as equal signs and go about my business solving for the indicated variable. For the y-intercept, you set your x coordinate equal to 0, so that one goes away, leaving you with your two intercepts being x as 3 and y as 6. So that's just another way to graph it. If you put it in slope-intercept form, you should have gotten negative 2x plus 6. That's just for you to check. All right, your next question is solid or dashed line. Again, it is, oops, that's really bad. A dashed line. Sorry, use your imagination. A dashed line, because I don't have an equal sign involved, and now I need to test a point. So I'll test 0, 0 again. So I'm looking right here to see if my solutions lie beneath my line. Testing 0, 0, you can test it either in the standard form or the slope-intercept form. If I put it in standard form, you're just going to get 0 is less than 12. Now, is that true or not? That is indeed true, so all your solutions will lie below your line. Let's have you do a guided practice problem. Here's your inequality that you need to graph, and you can either do it in slope-intercept form or standard form. So pause the video now and graph your inequality. Here's the solution, or all the solutions, and I chose to do mine using slope-intercept form, which resulted in something you might need to remember, and that is Here I had to divide by a -3 to isolate y, and you need to remember that when you divide by a negative, you need to reverse your inequality symbol. So here's a nice challenge question that you might need to know or be asked in the future, and that is to write the inequality that is represented by the graph. So there's a couple of important things to notice about this graph. The first is you have a dotted line, so you need to remember what that tells you about your inequality symbol. You also need to notice it's a vertical line, so which kind of variable, an x or a y, tells you that you have a vertical line. And then finally you need to notice that the right side is shaded on that line, so all that information will help us to write the inequality. First of all, because I have a vertical line, that means it's going to be an x equal for your variable. Next, I need to see which side is shaded of my vertical line, and because it is the right side, all my values of x are greater the further right you go, and so you are going to have a greater than symbol. Next, you need to see that it crosses the x-axis at a -2 because this is my origin there. So x is greater than -2 is my inequality for this graph. And here's one final example. We'll write the inequality represented by this graph, and we'll look at the same ideas. I have a solid line here, but it's slanted, so I know I have x's and y's, and I need to notice that it's shaded above the line. So you know you have a y, and I'm going to put it in slope-intercept form. So I'm going to have an x value over here, and I'm going to start by putting in my y-intercept, which is right here at a +2. So this will be a +2. I'm going to mark this so we can see it because I need to figure out my slope and where it's going, and it seems to have a slope of 1. I'm rising 1 and I'm running 1, so that you can either write a 1 in front of that x or nothing. And then finally I have to figure out which inequality symbol is going to go in here. And hopefully you've started to see some patterns that when you're shaded above your line that you end up having a greater than symbol in there. And then I need an equal to sign because it is solid. Now I never trust myself that I've done it right, so I'm going to test a point to make sure I have my inequality symbol facing the right way. And the point I'm going to test is one that's shaded in the overlap. So how about I pick -1, 2, 3, 4, 1, 2, 3. I'm going to pick -4 and 3. And plug those in your equation. X is a -4. And then clean it up. And ask yourself if this is a true statement. Is 3 greater than or equal to -2? And that is a true statement, so that tells you that you have your inequality symbol facing the right way. And so we could clean it up and say, here is my inequality that is represented by that graph.